If you haven't subscribed, ensure you do so. Two trains on separate tracks move towards each other. Train 1 has a speed of 1.3 times 10 to the power 2 kilometers per hour, which is here. Train 2 has a speed of 90.0 kilometers per hour. Train 2 blows its horn, emitting a frequency of 5.00 times 10 to the power 2 Hz. So this is the frequency that has been emitted by train 2. What is the frequency heard by the engineer on train 1? So below, this is the diagrammatic representation of the situation we have above. This is train 1 moving at 1.3 times 10 to the power 2 kilometers per hour. Then this is train 2 moving at 90 kilometers per hour. So the engineer is on train 1. So what we are supposed to do firstly is to convert these speeds into meters per second. So we convert the speed for train 1 and we also convert the speed for train 2. To convert the speed for train 1, which is 1.3 times 10 to the power 2, this is how we are supposed to do it. So 130 kilometers over 1 hour, which we have written here, multiplied by 1 hour over 360 seconds. So we know that 3,600 seconds is equivalent to 1 hour. So this is the relationship we have written there. Then 1,000 meters is equivalent to 1 kilometer, which we have written there. That's the relationship. So at this point, we can punch this on a calculator. So when we do that, we are getting the speed to be 36.11 meters per second. So this is the speed for train 1. Let's also look at the speed for train 2. So here we also do the same, 90 kilometers over 1 hour, which is here. Then the relationship for time, it's 1 hour is equivalent to 3,600 seconds, which we have written here. The equivalent, the relationship of distance is written here, which is 1,000 meters equivalent to 1,000 kilometers. So we also punch this on a calculator, and after doing so, we are getting our speed to be 25 meters per second. So this is the speed for train 2. So at this point now, we can introduce our formula. Frequency by the observer over velocity of sound in air, which is this one, plus the velocity of the observer is equal to frequency by the source over velocity of sound in air minus velocity of the source. So we can substitute the velocity of sound in air is 343. So in our previous videos, we mentioned that unless specifically stated the speed of sound in air, we will use 343. So in short, if they have not specifically stated the speed of sound in air, then we are supposed to use 343 meters per second. So we have substituted 343 meters per second plus the the velocity by the observer, which is 36.11. So this observer was moving towards the source, so it was positive. That's why here when substituting, we have substituted a positive speed. When we also look here on the right hand side of the equation, the frequency by the source was 500 Hz, which we have substituted here. Then the speed of sound in air is 343 meters per second. Then this source was moving towards the observer, so it was positive. And looking at our equation, when we substitute with a positive speed, it becomes negative. So this is what we have written here. So at this point, we can now calculate the frequency by the observer. So we can do that by just doing the cross multiplication like we have shown here. So this is how we are supposed to do it. And when we do that, we are getting our frequency by the observer to be approximately to 596.084905.7 Hz. So this is what we are getting. So this can be written to three significant figures as 596 Hz.